Hi everyone, hope that all of you are having an excellent start to the year 2025 and all of you have seen my earlier video which was about why 2025 is an extremely special number. Today we will solve an arithmetic problem which involves exponentials and high powers. So it might look complicated again, but we will solve them using the tricks of our awesome maths channel, right? So here is our problem for today. 2 to the power of 2001 plus 2 to the power of 1999 divided by 2 to the power of 2000 minus 2 to the power of 1998. Wow, looks very complicated again, right? But here we go to solve it. As requested before, please do subscribe to the channel and also share it with your friends and other children to whom it will be of help in their maths journey. So when we see a problem like this, our first step would be to put this expression in terms of a common power both in the numerator and the denominator. How do we do that? Here goes. So 2 to the power of 2001 plus 2 to the power of 1999 divided by 2 to the power of 2000 minus 2 to the power of 1998. Now this is the same as, now I can take out the 2 to the power of 1999 here. So I write this as 2 to the power of 1999 into 2 to the power of 2. So is this correct? 1999 plus 2 is equal to 2001, right? Plus 2 to the power of 1999. Now what I do in the denominator is the exact same thing. I write this expression in terms of 2 to the power of 1999. So this is 2 to the power of 1999 into 2 minus 2 to the power of 1999 into 2 to the power of minus 1. So 1999 minus 1 is equal to 1998. Okay. So proceeding further, this becomes, I take out the 2 to the power of 1999 on top. So 2 squared plus 1 divided by 2 to the power of 1999, 2 minus, now 2 to the power of minus 1 we all know is half, right? So we move forward. The 2 to the power of 1999s cancel each other. What do we get? We get 5 on top. 2 squared 4 plus 1 5. Bottom we get 2 minus half. So what is 2 minus half? It is 3 by 2. Now bringing the 3 by 2 on top, this becomes 5 into 2 by 3, which gives us the final answer of 10 by 3. So looks like an easy answer to again a seemingly complicated problem. And these kind of problems always come in a lot of Olympiads across the world as well as in pre-IIT questions. Now we will move on to our second arithmetic problem for the day. Alright, so here we are to our second question for this video. Find the value of cube root of 81 plus the cube root of minus 192 plus the cube root of 375 divided by the cube root of 24. Don't get scared if you see a negative number under cube root or these kind of numbers which are not perfect cubes. There will be a way to solve them, and that is what we will embark on. Now before we solve this problem, we will just do a little bit of rough work here, right? So okay, now let us do a bit of factorization of all these numbers. So 81, as we all know, this is equal to 3 into 3 into 3 into 3, right? So this is basically nothing but 3 to the power of 4. Okay. Similarly, minus 192. or let's just put 192 just to make it simple, is equal to 32 into 6, right? Which is equal to, so this is 32 is 2 to the power of 5, 2 to the power of 5 into 2 into 3. So this is equal to 2 to the power of 6 into 3, right? Okay, now we go to 375. What is 375 equal to? I think this we will have to do a bit slowly. This is equal to 5 into 75, which is equal to 5 into 5 into 5. So 75 is 25, which is 5 into 5 into 3, right? So this is basically nothing but 5 cube into 3. Okay, so our last number, which is the 24. 24 is equal to 8 into 3, which is nothing but 2 cube into 3, right? So why have we done these factorizations? You will just find it out soon enough. So let us write the problem here again. Cube root of 81 plus the cube root of minus 192 plus the cube root of 375 divided by the cube root of 24. So here we put the values of these numbers as they have been split up into factors. So 81 is nothing but 3 to the power of 4 minus 192 is nothing but 2 to the power of 6 into 3 and 375 is nothing but 5 cube into 3. Yeah, minus. Sorry, I'll put the minus here. Okay, we will just put it again. I hope that this is legible. And 24, again we have done the 24 here, it is 2 cube into 3, right? So divided by cube root of 2 cube into 3, right? Alright, so now we proceed. Now cube root of 3 to the power of 4, right? So what we can do is we can split this 3 to the power of 4 as 3 into cube root of 3, right? Because the 3 cube, it will basically come out. So let's see how to just do it in a long form. So this is nothing but 3 cube into 3, right? Now we can bring the 2 to the power of 6 outside. So we put this minus outside. So 2 to the power of 6, cube root of 2 to the power of 6 is 2 squared, right? 2 to the power of 6 by 3. So we will bring the, let us again do it in a bit of a long form just for everyone's understanding. 3 plus cube root of 5 cube into cube root of 3 divided by cube root of 2 cube into cube root of 3. Now what we can see here clearly is that now 3 cube root of 3 cube, what is that? That is nothing but 3, whereas the other 3 we just put the cube root here. Similarly here cube root of 2 to the power of 6 is nothing but 2 to the power of 6 by 3, which is 2 to the power of 2, which is 4 cube root of 3 plus 5 cube. So cube root of 5 cube is obviously 5 into cube root of 3 divided by cube root of 2 cube, that is 2 into cube root of 3. Now what we do is we take out the cube root of 3 as a common factor. So this becomes 3 minus 4 plus 5 divided by, so obviously the cube root of 3 is here, into 2. These two terms will cancel each other. So what do we have remaining? We have 5.
Okay, fine.
So 3 minus 4 is minus 1, plus 5 is 4. 4 divided by 2. So 4 divided by 2. So the final answer is 2. So again, a seemingly complicated problem involving cube roots of minus numbers, cube roots of large numbers divided by a cube root. But finally we see that the answer is just the small number 2. Wasn't that awesome?